we have this example on linear equation. 2 and then in bracket x minus 1, that equals to 5 divided by 2. So let's go. One thing we can do here is multiply 2 by what is in the bracket. 2 times x and 2 times 1. So we have 2 times x. It's 2 times x minus 2 times 1 equals 5 divided by 2. So you see that? I wrote 2 here is x. So it's 2 times x, which is 2x, minus 2 times 1, which is 2, is equal to 5 divided by 2. Now remember, the aim here is to get x equals, and then everything else over the other side. X alone equals. Right? So here now, what we can do is multiply both sides by 2. The reason is to get rid of the fraction. Let's consider that method. So I'm going to multiply by 2. If we multiply this by 2, each item separated by a plus or a minus must be multiplied by 2. Right? So you have 2x minus 2 equals 5 divided by 2. This multiplied by 2, this will multiply by 2, and this will multiply by 2. Remember, the reason why I multiply by 2 is to get rid of fractions. It's a bit easier to work on just numbers without fractions. Right? Just whole numbers. So 2 times x times 2 is the same as 2 times 2 times x. This really gives you 4x. Then you say minus 2 2's 4 equals 2 will cancel 2, so you have 5. Alright. Now, what do you do here? What you can do here to get rid of this 4 is to add 4 to both sides. So you have 4x minus 4 equals 5. Need to get rid of this 4, so I add 4, add 4. Because remember, I'm adding 4. Negative 4 plus 4 is 0. So what I have here is 4x equals 5 plus 4, which is 9. Alright? Now I want to get rid of this 4 from here. So what I do is divide by 4, so that I have x alone equals. I can't subtract 4 because 4 is multiplied by x. Division is what reverses multiplication. Alright? So in this case, I have 4x equals 9 divided by 4 divided by 4. So I have 4 cancel 4, so x alone equals 9 divided by 4. So that's what I have. Now let us look back at this. I multiplied by 2, but let's consider another way. Suppose I have 2x minus 2 equals 5 divided by 2. The aim is to get rid of the numbers that are mixed up with the x on one side, so I have x alone equals. suppose I should add 2. I'm going to add 2. We just draw a line here to separate them. I add 2. So I have 2x minus 2 equals 5 divided by 2. So plus 2 plus 2. Do I get? Negative 2 plus 2 is 0. So I only have 2x here. And that is equal to 5 over 2 plus 2. I'm going to fix up the fraction a bit later. Right? 5 divided by 2 plus 2. Now 5 divided by 2 plus 2. You have to remember your fractions and work this out. So remember, the reason why I multiplied by 2 before is to get rid of the fractions. The fractions will make it a bit more complicated. But here, I didn't get rid of the fraction this time, so we have to just work with it. 5 divided by 2 plus 2. Let's simplify this. It's plus 2 over 1. But I want common denominators here. Or you could find the LCM. Draw the line and find the LCM if you wanted. But if we multiply the top by 2, numerator by 2 and denominator by 2, what I get is 5 divided by 2 plus 2 2's 4 divided by 2 1's 2. This part will become 5 plus 4, which is 9 divided by 2. Right? Once you remember your fraction, you should understand what took place there. So, this is 2x equals 5 divided by 2. Now the thing is, I have a 2 here mixed up with the x. I want x alone. So what should I do? Well, divide by 2. If I divide by 2, I have 2x equals 5 over 2. Now here I have a division by 2, so 2 cancels 2, so I have x alone equals, nice, but what happened on this side? I have to divide by 2 as well. So if I divide by 2, dividing by 2 is the same as multiplying by a half. So I say multiplied by a half. When you multiply fractions, it's numerator by numerator over denominator by denominator. So here it's going to be 5 times 1 over 2 times 2. So you have 5 times 1 is 5 divided by 2. Where did I get 5 from? It's 9. Why am I writing 5 here? My mistake. This was supposed to be 9. This is 9. This is 9. Now, if in exam you make a mistake like that, just change 9 to 5 and it's obvious because you weren't concentrating on it, you wouldn't lose any mark. Alright? You wouldn't be punished for making an error like that. Right? Unless the marker is very strict in that. But normally, making an error in one part where it's not due to calculation and then using that to do the correcting in another part of the question, you're not punished for that. So it's 9 divided by 2. Alright? And you might make an error like that under exam pressure. So it's 9 divided by 2. 9 divided by 2. It's 9 times 1 over 2 times 2. So 9 times 1 is 9 over 2 is 4. So you see you get back the same answer. You have the same answer here. Alright, let's look at it again. Over here, let's look from this part and see what will happen if we make even more adjustments to our method. Just one more adjustment we're going to make. Here we added 4. Suppose when you reach this stage, 4x minus 4 equals 5. You say, could you divide by 4? You could. You could divide by 4. Right? Suppose we did that. What would happen? You would have a case where we divide by 4 here. If you should do that, you'd have 4x minus 4 equals 5. Each item that's added or subtracted must be divided by 4. So you divide this by 4 and divide this by 4 and divide this by 4. Right? So here 4 cancels 4, so you have x minus 4 cancels 4, 1 equals 5 divided by 4. Alright? Now at this point you could add 1 to both sides. So you have x minus 1 equals 5 over 4 plus 1 plus 1. So what you have is x equals 5 divided by 4 plus 1. You have to remember your fraction calculation again. If you say 5 divided by 4 plus 1 is the same as 5 divided by 4 plus 1 divided by 1. But let's draw the line and find the LCM here. Could use common denominators like before, but let's look at this. 4 into 4 goes 1 time 155 plus 1 into 4. There are 4 1s in 4. 4 multiplied by 1 is 4. So what you get is 5 plus 4 is 9 divided by 4. So you get 9 divided by 4 again. Alright, so that's it for this video. I'll see you in the next video.